Hey there, I wanted to go over some solving by completing the square examples as well. I know these are tricky problems sometimes. I'm going to do this a little differently than maybe I showed you in class. I did do like a couple different, I'll say, methods when we're looking at completing the square, and I think maybe that's confusing some people, so I want to just go back to like the very first thing we did was rewriting this equation that was in standard form into vertex form, and then from there we'll solve it. I think that may be simpler if we just focus on that one kind of look and see if that helps you, not have to remember so much. So just like we do with solving by factoring, we want one side to be 0, so we got that, so we're looking good, because again we're looking for those x-intercepts. We want the y to be 0. So if it does ever say y here, just turn that to a 0 first off. But then the idea is, we want to turn this into a perfect square. And so we, like we talked about in class, we look at that b value here, and so that's at -8. And so, -8 divided by 2, of course, is -4. And what that tells us is how big the dimensions of our square are going to be. That it's x, and then -4 by x minus 4. And so we see our area of x squared, and then -4x and -4x. But those aren't really the parts that we really need to be paying attention to, because x squared, we already have that, and -4 and -4 give us -8x's, which we already have. It's this here that we really should be worried about is what's going on in this bottom right. And so as we look at that bottom right square, think about the area of that square. Of course, -4 times -4 is positive 16. So this has an area of positive 16. And so that's what a perfect square would look like, right? The bottom right would have an area of 16, but if we look at our equation, again, we have our x squared, that's there, and we have the -8x's that are there, but we only have 7 ones here. And so it's this idea like, well, if I break this up there, it's 4 boxes, 5 boxes, 6 boxes, 7 boxes. So a bunch of those boxes, aren't there. And so like, how many boxes are missing? Right? Well, I have 7. I'm supposed to have 16. Right? 9 are missing. And so, how do we figure? So we're short 9 boxes. So another way to do that is, once you do know what that perfect number is that you have down there, instead of having to sit here and draw boxes out, is to take the number that you were given, the 7, and the number that you wanted, the 16, and you always subtract them. It doesn't need to be in that order. So the one that you were given minus the one you wanted. So if you do in that order, it says that we're short 9 boxes, like we said we were, -9, right? It's -9. So we hold on to that. Sorry, that idea that we're short 9 boxes. So we say, we have a perfect square, this x minus 4 squared. And I guess this is the key step, to go from this quadratic trinomial into this binomial square, that this is equal to x minus 4 times x minus 4, but we're short 9 boxes. And so now it's in vertex form. So once we have it in vertex form, then we can solve it just by using SADMAP, by getting x by itself, undoing the problem. So I'm going to add 9 to both sides. And then we're going to look on the outside for any division or multiplication to do, which there isn't any division or multiplication out here. So let me undo that exponent by square rooting. And so remember, the square root of 9 is 3, but it's also -3, so that splitting idea, x minus 4 on both of those. Then we want to add 4, add 4. And so we get x equals 7 and x equals 1. There's our 2 x values. Okay. So we focus on that b value. We use that to help set up our box. Divided by 2 helps set up our box. Figure out what that bottom right number should be. Take what we have minus what we should have. Now tell us how short we are. Go back to the dimensions of the box, x minus 4 times x minus 4. What we were short, and then we start solving it. Okay, let's try that again. So I look at my b value. So 18 divided by 2 is 9, positive 9. So I'm going to set up my box. And some of you guys are moving past needing to do box. That's great. So x plus 9, x plus 9. Again, I'm not really concerned about these three. Those are always going to work out. It's this bottom box I'm worried about. What's the value there? So, of course, 9 times 9 is 81. So I should have 81, but I only have 53. So here's where I take what I have, 53, minus what I should have, which is 81. See how short I am. We are short 28. Okay. So this is the key step. We have a perfect square, right? How big is our perfect square? It's x plus 9 times x plus 9. So x plus 9 squared. Well, we almost have a perfect square, but we're actually short 28 units. Okay. So I was able to rewrite this standard form problem into vertex form. Okay. Once I have it in vertex form, I'm going to start to solve it. So I'm going to get x by itself. I'm going to use SADMEP. All right, SADMEP. Any subtraction addition I can do first. All right, so I want to add that 28 over. Look on the outside of the parentheses for any division multiplication. Yes, there's none of that, so move on to exponents. So we're going to square root both sides. So on the right side, we're going to get x plus 9. And just like before, we're going to get two different two different values over on the left side. But we have to figure out what that is. So what is the square root of 28 equal to? So we use our sock here. Let's come over to the left side and figure that out. So the square root of 28. So I want to take that, divide, take 2 out, we get 14. 14 is equal to 2 times 7. So I've got a pair of 2's, so 2 gets to come out. I've got my lonely 7, so 7 has to stay in. So I get 2 radical 7, but I also get negative 2 radical 7. Okay. So the square root of 28 is equal to 2 radical 7. It's also equal to negative 2 radical 7. So I've reduced my radical, since 28 was not a perfect square. And then we want to subtract 9 from this side. Subtract 9 from this side. So we talked about in class, it looks kind of weird. Right? We're saying we want to subtract 9, but we can't really directly subtract 9 from that since they are different types of numbers. But we just write it out. X equals, so we got negative 9. So the normal number should go first. And then the positive 2 radical 7. And the next one, we got x equals, so my negative 9. And this time minus 2 radical 7, so negative 2 radical 7. Okay. So there's one that has what are called complex answers. And that's something we're going to be seeing more and more here of. Okay. So there's 2 I want you guys to try, and I want you to bring that to me and show me how you did. Okay? Good luck.